Hi everyone. In this video, I will discuss two ways of client and server interactions. One is session and the other is JWT. We will see various architectures with session-based interaction and their shortcomings and see how JWT addresses those in the modern architecture. We will wrap up with a hands-on demo where we will create an express server using Node JS that generates a JWT token upon successful user authentication. For protected endpoints, the client must send this token in the header. The server verifies the token and rejects a request if the token is invalid or expired. So let's see in a traditional session-based approach how client and server interaction happens. A client makes an authentication request. The server validates the parameters passed, for example, username and password. Once server validates and authenticates, it generates a session ID, which it stores on the server and is also sent back to the client in the form of session cookies. The cookies are sent back whenever the client tries to access a protected endpoint. Server verifies what the information that comes in the cookie against what is stored on the server. If the verification is successful, the server allows the access to the protected endpoint to the client. Let's see some of the issues that it poses. Let's say we have a server. We have a client that connects to the server. When the authentication call is made, the server authenticates the client and generates a session and stores the session in memory. Same happens for the subsequent clients as well. Now, what is the issue with this approach? Well, if the server goes down, we lose all the sessions. Second thing, it's not scalable because one server has limited resources and it can only support a limited number of users. So we improve this architecture by having a load balancer and multiple servers which serve various user requests. So as you can see, each server after authentication again stores the session ID in memory on that server itself. Load balancer is also enabled with sticky session. So a user session on server 1, load balancer would always direct that user to server 1. Now, there is slight improvement with what we saw on the first approach where there was only one server, but this one still has a problem. What happens if server 1 goes down? The load balancer will start sending the user 1 and user 2's request to server 2 and 3, where the user 1 and user 2 have no sessions. So they will have to re-authenticate, which is very annoying to the customer. So as we say, if the server goes down, you will lose session on that server and users will have to re-authenticate. How can we alleviate this problem? Okay, let's see another approach of designing with a session-based flow. We have a load balancer as before with multiple servers and multiple users sending requests to the individual servers. Now in this case, instead of storing the session on the server itself, we store the session on a distributed in-memory cache, for example, Redis. Now, even if the server 1 goes down and user's request is directed to server 2, server 2 still has access to the user's session data, which is stored in in-memory cache. So, any server can serve that user's request. Much improved architecture than before. So, sessions problem where the server goes down is solved. No sticky session, which makes it much more scalable. But there is one problem. Redis can become single point of failure. If the Redis goes down, then all the sessions are lost and every user would have to re-authenticate. To alleviate this problem, or all these problems with a session-based architecture, the JWT comes into picture. With JWT, servers don't store anything about the user session. They generate a token and give it to the client. Now it's client's responsibility to send the token along with every request, which server then verifies. So let's see the flow, how this works in a client-server interaction using JWT. Same as before, the authentication request is made and the server authenticates. Once the server successfully authenticates a user, it generates a JWT token. This token is not stored on the server. This token is sent in the response back to the client. This response could be part of the body or could be sent in the header. For any subsequent access to any protected endpoint, the client must send this token in the header. Server verifies this token, and if the verification is successful, server allows client to access the protected endpoint. Now we solve the problem of multiple servers and servers going down, or Redis or in-memory cache going down, because there is nothing stored on the server. Server gets the token and it validates it, and it allows the user access based upon the verification. What is JWT? JWT is a short form for JSONwebtoken, and it's an open standard that defines a compact and self-contained way of securing and transmitting information between parties. It is trusted because the issuer, like our server, digitally signs it. It can be signed using a secret, which is what we will see in the demo, or a public or private key pair. One thing to note that JWT is strictly for authorization. It's not for authentication. You still have to validate your user, whether it's username, password, or any other combination that you use, but you have to validate the user's authenticity before issuing them a JWT token. JWT is used for authorization and information exchange. Authorization is a very common case. After a user is authenticated, each subsequent protected route or service request can include the JWT in authorization header, which server can verify. Information exchange, a very common scenario is generating the JWT token using public and private key pair. So the receiver and sender, they both trust each other. Let's take a look at JWT structure. This is a sample token. I have color coded 3 different parts here. Let's see each one of these parts in detail. Every JWT token has 3 parts. The very first part is header, next part is the payload, and the last part is a signature. Every part is base64 encoded, and they are concatenated by period. It makes the entire JWT token. If you take individual parts of the JWT token and run it with base64 decode, it would look something like this. If you see, the header has the information about what kind of algorithm was used to create this. Payload has all the information that your server would need to understand the client, that this is who this client is, and this is what his access level is. For example, the client ID, maybe some sort of groups that you have access to. For example, one person could be a publisher, one person could only be a customer, etc., and an expiry time. And the third part is the signature, which takes header and the payload, make them base64 encode, and use a secret key which your server only knows. This secret key cannot be tampered. If somebody, let's say, tampers the JWT token, and they would not know your secret key. Once server gets the token and verifies using your secret key, it will not match and the request would be rejected. As we have seen, JWT is definitely an improvement on the session-based approach. Since it is not stored on a server, any server can serve the client's request, making this solution much more scalable, as it is not dependent on routing the request to a particular server. But does JWT solve everything? Well, of course not. Some of the issues to look for are stolen JWT. If a JWT ends up in the wrong hands, a malicious user can access a protected endpoint by sending the JWT in the header. As long as the JWT token validation is successful, server will honor the request. How do you prevent such a thing? Well, we can maintain a blacklisted JWT list. This will be a maintenance nightmare though. Another approach is we can change the secret key on the server, which will make all the older JWT tokens invalid. Although not an ideal solution, but it would prevent the damage that a hacker can inflict upon your system if he or she gets hold of a valid JWT token. Another common problem is JWT with longer expiry. Longer the expiry of JWT token, more are the chances that it may get into wrong hands. You should design your token's expiration carefully and refresh the token more often. Now is the demo time. In this video, we will demo JWT in action, or how it can be used for authorization and protect the endpoints. We will create a simple express server exposing three endpoints: an unprotected endpoint, a login endpoint, and a protected endpoint. Our goal is to generate a JWT token or JWT token upon successful login, which should be sent as a bearer token in the authorization header. Any request to the protected endpoint without this token or invalid token should be rejected. Any unprotected endpoints should continue to work without the need to pass an authorization header. Let's start. Here we are in a terminal, so let's create a new folder. JWT demo. We'll do npm init and accept all the defaults. Let's open this in the Visual Studio Code. Okay, so in Visual Studio Code, we will install a couple of node modules. Npm install express and JSONwebtoken. Let's create a simple file, index.js, and then let's write our code to create a server. So let's see. I will say app equals to express and app.listen. Let's listen to port 3000. And just to log a message, console.log server started. Let's create a route. Let's create a route to do a get. We'll just say app.get. And we'll send a simple JSON body, response.json, and let's say body is, this is unprotected route. Let's test this real quick so we can confirm our setup. Let's say node index.js. Server is started. Let's access this server on port 3000. And yes, so we are able to see this response. Let's continue. So I'll stop server and we will actually run the node so that we don't have to restart server every time to get the changes. -- watch. Okay, so I'm going to create two more endpoints, and let's call this /my account, and for now I'll just say this is my account endpoint, which will protect using the JWT token. We will also create a login, and this will actually be a post. This is login route. Let's try to access each one of these endpoints once so that we are sure that it's all working fine. If I go to /my account, this is my account endpoint, and for the login endpoint we actually have to make a post call. So let's go to the postman and let's create a new collection. Let's call it JWT demo, and I will create some endpoints in here. So let's say new request, not login, for example, and make it a post. And in the body, we'll just send a simple body. For now, let's say username, let's call it GG test, and password should be password. So there's no authentication at this point, and our post login endpoint works. It says this is a login route. Now let's add some logic so that we can fail if the authentication token is not there, if the username password is not working or not correct in the login, we can reject this, the request with some error. So let's start putting some logic in there. So first thing, let's import JSONwebtoken. JSONwebtoken. We will also use .use so that we can parse the JSON. Okay. Now in the login, let's put some simple logic that we say if request.body.username equal to GJ test, and then request.body.password equal to password. We are just doing a simple check, but this is where you will actually make a call to your database or wherever you store your username and passwords and the credentials. If so, we'll create a payload. And let's just put a fictitious ID of this user. Let's say that's 1001 and name. And maybe website, mycloudtutorials.com. That should do it. And then in the body, let's just send this payload as a response. So what we'll do is we'll send this as a response. If it doesn't work for whatever reason, the username and password is not correct, or it's not found in our system, or they don't match, in that case we will just reject this request with an error. So we'll just say response.status, let's call it, let's send 400, and we will send a message invalid user password. Okay, let's test this. So in this case, my password and the username, they are both should match this criteria, and I should get a response body. So let's see. Yes, and I'm able to get the response body. If I try to send a wrong password, or sorry, wrong username, so I get a 400 bad request. So our logic till here is working just fine. What we need to do is, this payload we will actually send as a JWT token. So if this is successful, we will create a JWT token from this payload. So let's say const token equal to, let's just call it .webtoken dot sign, and it would need a payload and a secret. So before that, let's create a secret. We'll say const our secret key. Let's keep it simple, mycloudtutorials.com. This will actually be coming from, this will be a secret stored in a secret place like Vault or SSM, AWS parameter store, or somewhere. For the simplicity, we'll just store it on the server and use this for generating and validating the JWT token. So what are we signing? We're signing this payload with this secret. And instead of returning the body, in the body, I can return that the user is successfully logged in. So we will return this JWT token instead of this payload. So let's try this. And yes, I got this JWT token back. If I take this JWT token and go to JWT.io, we can use the debugger to see what kind of information is being sent. So if you see here, this is a header which tells you what kind of algorithm was used to encrypt this. This is the payload, and this is the verify signature. So if somebody tampers with this and sends me a JWT token, let's say I make a Girish, or say it's one here. In that case, this will be invalidated on the, or it would fail the verification on the server. So now we got our JWT token. So let's create a my account route where we will send this in the authorization header. So before that, let's see, we have to create a middleware for the my account, and we'll just say, let's call it ensure header. This is in the ensure header, we will do a few checks. Function ensure header, and it gets request, response, and next. Here we'll first see whether the request has authorization header or not. So const, let's see, auth header equals request.headers and authorization. If no authorization header is passed, auth header, in that case we reject the request, and we reject it with 403. Response dot send status 403. If it's there, we have to see what the value is and verify it with the JWT token. So in that case, we'll just say const, let's call it auth header well equals we'll send as a bearer token. So there will be token sent like this, bearer space and whatever is your token. So that's why we are splitting it here with the space. now get the bearer token. That's the second element of this array, so we'll mark it as 1. Now we will actually validate it against the JWT. So JSON web token and dot verify. Here we'll pass the bearer token and a function, bearer token, our secret key, and a function that would have error and data. Now if we receive an error from this verification, if error, in that case we just have to reject the request. We just say response dot send status 403. Otherwise, let's get the ID from the data. So we'll say request dot user ID equals to data dot ID, which is what we are putting here. That's the ID we want. I mean, this ID can then be used for other purposes, but what we are trying to do is, like, from the bearer token, we have validated the user is authenticated, he has authorized to access this particular endpoint, this is his ID, and he can only access, let's say for example, we want to display his last orders on the my account page, so that's why we need the ID of the user. So request.user_id is the ID, and we call next. So in this case, the ensure header, when we try to access my account endpoint, ensure header middleware will be invoked. It will check whether the authorization header is there. If so, if it's not there, it's rejected with 403. If it's there, but it cannot be verified with our secret key, in that case also it's rejected. Otherwise, we'll stick the user ID from the bearer token and pass it to, or make a call to next, which means it will allow you to go to this particular endpoint. So in this part, this is my account endpoint, and we'll also send user ID back so that we know that this is retrieved from the bearer token. Request dot user ID. I think that's all. So let's try to test this. If I go to my account, let's create a my account endpoint, duplicate this, let's call it my account, and we'll try to access my account. This is actually a get. Let's try to access it without any authorization headers, and we should get a 403, which is good, working fine. Let's take this particular JWT token that we were able to generate with valid credentials, go to my account. In the case of headers, let's send authorization, and we'll send a bearer token. If I send this, yes, so my account endpoint is able to validate or verify this JWT token, and is returning a success message where we can see user ID, which can further be used for other functions on the page. If I send a wrong bearer token, for example, let's try to change this. If I send this time I got 403 again, because I have this verify that must have failed and gotten me an error, and I'm not able to access my account at this point. Let's try to access the home page, which is the unprotected route. So I'll just duplicate this, and let's see get, and let's call it home route, for example. There is no protection on this, so this should continue to work as expected. So that's all for this demo. In this demo, we were able to create a very simple Express server using the JSONwebtoken library. We were able to create a JWT token once the user is successfully logged in. and we were able to protect the endpoints using this JWT token. I hope you like it, and I will see you in the next demo. Thank you so much.